Now we will be discussing about another data structure, very important one, called tree data structure. Okay. What exactly is a tree? Tree is one of the most important non-linear, see the important thing, non-linear. Linked list is a linear data structure. Tree is a non-linear data structure in computing. It allows us to implement faster algorithms. So there are a lot of algorithms, especially search and all, which are much better in a tree data structure than any other data structure. It allows us to implement faster algorithm for various purposes. Now define tree. A tree is a set of nodes storing elements in a parent-child relationship with the following properties. What are the properties? It has a special node called root. Each node is different from a root. From a root has a parent node. So except root node, everybody has a parent node. So for 2, this is a parent node. Okay. For 7, this is the parent node. For 9, this is a parent node. For 4, this is a parent node. For 3, this is the parent node. Okay. And obviously, this one is called root. The value can be anything. It is just that root is that node which has no parents. Okay. Here there are a lot of example scenario where we might need a tree kind of a data structure to explain something, like family history. Jane has these kids, Matt, Jennifer and Brian. Brian has these kids, Jerry and Jack. These are okay. Lot of things, the organizational structure, a CEO, below that there are vice president will have a assistant vice president, associate vice president, they will have a director. So all that structure and lot of real life structure of information requires a tree kind of a data structure to store the data and information for us. Now in a tree terminology, there are some basic properties and terminology. So we'll just understand about each one of them. First is sibling. Sibling means 2 nodes are siblings if they have same parent. Ancestor and descendant. Ancestor, everybody who is parents and all those, they are called ancestors. Descendant, everybody below that is called descendant. Leaf, a node which has no child. Subtree, any node and its descendants form a subtree of the original tree. So you can take any node and subnode and its descendant, it will form a subtree. What is a path of 2 nodes? A path that begins at the starting node and goes from node to node along that join them until the ending node. So how will you do that? Let us see this. So let us assume you have a node. This is the binary tree. Now path from A to this is this one and this one. That is called path of two nodes, this and this. Length of a path, the number of edges that compose it. 1 and 2. This is the length of the path. Depth of a node, the length of the path between the root and the node. Sometimes this can be root, sometimes there may not be root. So when you are calling from root, that is called depth of a node. Height of a tree, among all the nodes, which has the maximum depth, that will call height of a tree. What are the different types of tree? There are three different types of tree. One is called binary tree, where each node has at most two children. See the concept, at most two children. It does not mean always two children. That is the other confusion which happens. There is a difference between at most and always. This is also a binary tree. This is also a binary tree. Because binary tree does not say that each parent will have two children. It only says that maximum it can have two children. It may have one child also, and it is still binary tree. N-ary tree means each node has at most n children. So keep in mind this at most. People generally overlook this at most part. What is general tree? General tree means there is no fixed number of children. It has arbitrary number of children. Okay. Now tree data structure has various methods, access methods and query methods. Get a reference to root, so that is the root method, parent method, children method. If you give the node, it will find out all the children nodes of this given input node. If you give a node, it will find out, this method will find out who is the parent of this node. Okay? So that is called parent node, root node and children node, children's node. This is an iterator because a parent can have multiple children. At least in binary, there can be two children. So it will give you an iterator to that two node. Query methods, there is a method called isLeaf. What it does is that it will take the node as an input and it will check, is it a leaf node or not? If true, then return true or false. Is it a root node? And then there are some generic methods like size, elements, nodes, swap elements. So you can swap the elements between two nodes. You can have node 1 goes to node 2 and node 2 goes to node 1. You can have a particular node's element also replaced. It is like a set in linked list. Now let us understand what are the two types of binary tree. We know that in binary tree, each node has at most two children. But binary trees are of two types. One is called full tree. Other is called complete tree. A binary tree is full if every non-leaf node in the tree has exactly two children. So if you leave the leaf node, other than leaf node, everybody else should have exactly two children. What is the complete tree? A binary tree is complete if every level except the deepest contains as many nodes as possible and all the nodes at the deepest level are as far left as possible. So just be careful about this definition. If every level except the deepest contains as many nodes as possible and all the nodes at the deepest level are as far left as possible. A complete binary tree of depth n has these properties. Maximum level number of leaves is 2 to the power n and maximum number of total nodes is 2 to the power n plus 1 minus 1. Here is an example of full binary tree. What it says is that every non-leaf node has exactly 2 children. So this one has, these are the leaf node. Okay? Go the definition. What it says, a binary tree is full if every non-leaf has exactly 2 children. Now in this one, these are the leaf nodes, so leave it. These are the leaf node. We have to find non-leaf node. So non-leaf nodes are this, 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 and this. These are the non-leaf node. Now check, does every non-leaf node has exactly 2 children? Yes. It means it is a full binary tree. Now check out what is a complete binary tree. Complete binary tree says a binary tree is complete at every level except the deepest contains as many nodes as possible and all the nodes at the deepest level are as far left as possible. So what is the deepest level? This is the deepest level. Okay? So this is the deepest level. This is the deepest level. Okay? Now except the deepest level, all the nodes have as many as possible. At this, true, true, true. And even if 1 or 2 was not here, it was still a complete binary tree. Now the question I have is every complete binary tree is a full binary tree? Can we say that? Can we say that a full binary tree is always a complete binary tree? Think about this question and analyze it. Let me repeat the question. Can we say a full binary tree is always a complete binary tree? Or can we say a complete binary tree is always a full binary tree? Which of these two statements is correct? Or if both are false, then explain why. How can you use a vector to store a binary tree structure? The way we store a vector, use a vector to store a binary tree structure is like this. First, what you will do is that you will draw the tree structure. This is the tree structure, and then you will put 0 and start counting like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember this, there is nothing here, but I still counted 9. There is nothing here, but I still count. So 9, 10, 11, 12, 13, 14. So this one I counted as 13. This one I counted as 12. This one I counted as 11. 11, 12, 13, 14. What it means is that you should count like this, and whatever the value comes here, for that size create an array and put whatever the indexes I have put it here. Accordingly you should put it here. For those where there is a blank like this, this is 9, this is 11, this is 12. Okay. Now, in a vector-based structure for binary trees, let us see how these things works. So, nodes and elements method runs in order of n. Swap and replace works in order of 1. Root, parent, children works in order of 1. Left child, right child, sibling works in order of 1. Is leaf, is root works of order of 1. So, see these things. All are of order 1. Okay. What are the pros and cons of binary tree? First of all, it is very fast and easy. Can be very space inefficient if the height of the tree is large. Now, here is first exercise for binary tree. If the number of nodes in a binary tree is 5, what is the size of the vector in worst case? So, remember what the question is. Find the vector, size of the vector in worst case. How can you create a binary tree using linked list? For that, first you have to create a binary tree node. And it will have left, right, and parent. Here if you see, there is a left node, there is a right node, there is a parent node. So, these 3 nodes are there, and there is a main element object. If you are going to implement your binary tree using linked structure, then these are the order of algorithm for linked list.